something.
Yes, sir.
So coming to my slide, I think you can see it. We have already done those story. 90% limit, 95% limit. So only thing is that it is very easy. We are talking about the population means from sample. And we have shown you how to now see this diagram, and we need to know something on that. So basically, few terminology, you must be clear. You should not get confused. We are using what distribution? We are using Z distribution, because this is Z distribution. And there is some nomenclature in your textbook also. And this is minus Z alpha by 2. I'm just giving a name, normally minus 1.96, for example. And what is this area? This is plus 1.96, for example, the number. And this area is just, for example, 2.5%, 2.5%, right? So 0.025, this area is 0.025. So basically they are telling in terms of alpha, 1 minus alpha, the same concept is coming. You see, when I'm talking about 90% confidence, so that means 90, or for example 95% confidence, if I'm talking about, that means how much remaining percentage? 5%. That means 0.05 is called alpha, 95% confidence. So these wordings are actually similar. So when I'm talking about 95% CI, that means we are going to talk alpha value for me is 0.05 is the alpha. In that case, you see, we are talking now, alpha will be 2 times divided. So this area is alpha by 2. This area is also alpha by 2. So remaining area is 1 minus alpha, that is 95% we are speaking. Why I am telling this? Because you see, till now I was telling about minus 1.96 plus 1.96 or minus 1.64 plus 1.64. Hey, that is very difficult. You have to give some name. So for sake of name, so Z alpha by 2, what does it mean? It is actually 1.96, for example. Minus Z alpha by 2 means minus 1.96. So this thing we have already studied. I am not talking anything new. I am just telling this area, we are just giving a nomenclature so that it is more easy for you to read. And we have already done this. So what is the mu interval? Now this is the interval. X bar, mean value 1.96 something was there, and sigma by root n. We have already done some problem. I think you remember. Yes or no? Is it clear? Only thing is that I was just, instead of telling the number, I was telling some nomenclature. That's all. Now, until this, everything was very nice and happy. But I have to tell you, no, this is not going to help you much. Because in interval estimate also, we were assuming until now, listen very carefully, that we were assuming that sigma square we know, right? That was our definition. That was the starting point we discussed about Z distribution. If you don't know sigma, sigma is what? Can anybody tell me what is sigma? It is a population standard deviation, right? Population standard deviation. But most of the time you don't know that. So who will give you the sigma value? I asked you multiple times when you are talking about Z distribution. But now you come to practical. That means I assume that we do not know the population variance. Of course, I'm sorry, here also. This is also unknown. But we want to know that now. We want to know about mu. That is the purpose. Okay? We want to know. So basically same thing, but now I'm assuming that sigma square is not known. Then what will happen? If sigma square is not known, then root n x bar minus mu by sigma, will it become a standard normal? No. Try to understand. Standard normal is only possible. When standard normal is possible? When I know that there is a normal distribution whose mean is mu and variance is sigma square. If we know that there is a normal distribution having mu value and variance sigma square value, and then if I make x bar minus mu by sigma, that time I told this is also known as standard normal, right? Standard normal distribution. But logic is that if sigma square we know, but if you don't know, then x bar minus mu by sigma you cannot deal. But what we can have, we are having a square. We know the sample variance because you are taking some 5 or 6 sample or 10 sample. I know the sample standard deviation, sample variance we know. And for sample, we use normally term of S. Please be careful. When we are talking about a population, then we are talking about mu, we are talking about sigma square. When I'm talking about sample, sample is very small and you can measure. This you can never measure. Sample you can measure. That means you can have sample average and sample standard deviation. That only you can measure, right? Very simple. You know how to do that. Now I'm going to utilize the same thing. I am not getting any feedback from you. That's why sometimes I feel whether you are going in track or not. Is it okay to understand that whatever we assumed earlier is not going to help us? We have to come for sample basis.
Yes,
But
sir.
but we know that sample variance is known, and we will try to tell you that there is a new things will come. What is the definition of standard deviation? You remember, standard deviation is your x sample. This is sample standard deviation, and we already know that. If you don't know, just check it. Sample standard deviation means each sample value minus its average square divided by n minus 1 square root. You remember, na? If I tell you 3 number, 2, 3, 4, what is the standard deviation? How you are doing? First you are calculating the average. Average was, for example, 3. Then what I am doing? 2 minus 3 square, then plus 3 minus 3 square, plus, you remember, na? Then I am making their sum and dividing by n minus 1. Then I am making a square root. You remember that, I believe. So this is the standard deviation. Now we are coming. We are telling that no. If I want to use, instead of the same trend, if I want to use S, root n x bar my x is a normal distribution, I know. Mu I don't know, but we want to find it out. And instead of population standard deviation, I'm using sample standard deviation, and it is known to be a T distribution. T distribution is another kind of distribution which is very similar to normal distribution. So I'm coming to one another. Normal distribution, you are so happy. But what is then T distribution? T distribution has a definition of its own. I am telling that, you see, X is normal, right? Yes or no? I told X is normal. I also know that x bar minus mu will also be normal. That is no problem. Yes or no? If I subtract something, if I add something, do you remember in our very first classes we were talking, if I am having normal distribution, if I add 2 normal values, it is again normal. If I multiply by something, it is normal. If I add something, it is still normal. So basically, x bar minus mu will be definitely a normal distribution. And x bar minus x square by n minus 1, that part, any number minus your normal distribution values, x minus x bar square by n minus 1, that is called chi-square distribution. The definition of, okay, I have not talked about chi-square distribution. Chi-square distribution is also one kind of distribution, but it is different. It goes like this way. It is not a symmetric one. So this actually, it looks like similar to variance values or standard deviation values. So this is becoming a chi-square because it is sum of normal random variable square values. Anything, you see, x is normal. Clear? X bar is definitely going to be a normal. X bar minus any value, it's also going to be a normal. Its square term is known as chi-square. So basically, when I'm adding those x square values, that is called chi-square, and this distribution is known as chi-square distribution. And I'm coming very quickly. Chi-square distribution, if I am having something, and then if I have some divisor here, S is going to be a, what is S? Square root of this one. So this is going to be known as T distribution. I hope I am not very clear, but I'm just trying to make you one more time repeating. If you follow me, then it will be easy for you to understand why I am talking about this. First thing is that what we know, you please keep in mind. What is chi-square distribution? Okay, I'll just go 1 second. Not much, but I do not have that in my syllabi, so I'll the definition of chi-square distribution I'm telling. If something square, some variable, for example, I'm having y1, y2, all those things are there, and if I make their square one normal distribution, so for example, I'm having a standard normal distribution. So these values, whatever value I'll get now, if they make their square term, so for example, this is x, its square, x1 square or something else, that distribution, the summation distribution, you understand now? For example, if I say x is a normal distribution, if I take any sample, the sample will be normal, yes or no? I may get 2.1, I may get 2.3, I may get 2.5. If I want to check their values, it is also a normal. Now I am telling, from a normal distribution, you take values and make their square. If you do this, it will not be a normal distribution. I'm telling once again, it will become a chi-square distribution. It is known as chi-square random variable. You are making square term, square of the. So basically, what is chi-square? Chi-square is square of normal distributions, normal random variables values, and their sum. So basically, sum of normal square, normal square, normal square is called chi-square. And if I'm having a chi-square distribution, I have not shown it here, but chi-square distribution will be also very similar, but it will also having some degree of freedom, and it will not be like a normal. It will have one end. Here we have not shown the graph, but we can show you. So basically, now coming to our discussion, why this thing is talking. So what is the definition of T distribution here? You see, T distribution is defined by a standard normal distribution divided by chi-square distribution by n. That is called T distribution. Oh, why I'm saying like this? Chi-square definition I told. And here also, I'm just in the next 2 slides I'm going. Sorry. What I told here? I told that this is a chi-square. What does it mean? I am going to say that S value or A square is having, you see, you see very carefully, A square is going to give a chi-square distribution. Yes or no? S is square root of. So A square is like the same thing, because it is sum of square term. That's why it is a chi-square thing. Now, if this is the case, A square is a chi-square thing. Now coming to back here. Here. So when I say T distribution, what will be T distribution? Z by root over of chi-square by n. That is called T distribution. You see, this looks like chi-square by n is basically going to give us very similar values of standard deviation instead of this, because chi-square itself is, what is the definition I told? It is sum of, you see, xi divided by x average square by n minus 1. So square root of this means what is happening? It is becoming like a standard deviation kind of things. So basically we understand that this chi-square by n, this value is going to call, or this is going to, if I'm using, and this anyway we can term it as standard deviation of sample. Now coming to my point of discussion here, where we left. It will be too early, but anyway, we have to move. So basically, I can say the things remain unchanged. X bar minus mu by S. That is going to give you a T distribution aspects. Where you started? We told that if X is normal, we told that if X is normal, then X bar minus mu by S, that is going to give you Z distribution. But this time X bar minus mu by S is going to give you T distribution. And T distribution is also very similar. I think I have shown you some graph in coming slide. Yeah, this is called T distribution. You see, it looks like normal only, but it is not exactly normal. Then what is the definition of T? Definition of T you should understand. T distribution means, I told you, it was Z divided by chi square by n. What is chi square? Chi square is actually x1 square plus x2 square. That is called chi square. So basically sum of square by n. Am I clear? This is chi square. So Z by something is called T. So in our case also same story is happening. You see, X bar minus mu. Here I am using, instead of this I am using S value instead of sigma, and that is called T distribution. So basically I am coming to conclusion here. What conclusion I am going to do? I am going to do, in practice you should use T distribution table rather than standard, normal or Z distribution. That is more applicable, more useful for anyone in this kind of study. But you see, the things are not changing much. You also use the similar kind of equation for Z. Earlier you have used Z alpha by 2. Now I will be using T alpha by 2 n minus 1. T alpha by 2 n minus 1. So T distribution need two things. Not only the alpha, I also need to know how many samples are there. Degree of freedom are also needed. So basically in practice we will be using T distribution data for calculation. You see, otherwise the definition remain unchanged. There is no change when I am talking about the distribution parameter or in the statistics part. Is it going to come to you in some sense? This is no longer Z. This is a new distribution terminology itself coming, and that is called T distribution. That's all. Now all other aspects will remain unchanged. Nothing is going to change for you. You see, the same story will come. Probability of this portion, probability of this portion, 90% this one. These all story remain unchanged. That is no point. Only thing is that this value I need to know. Now question comes. So if we are talking about Z distribution, T distribution, so many things, but basically you see, that is called T distribution. Na? If I am having n is very big number, if n is too high or too big, if n is too big, this chi square by n value is becoming very close. Chi square value and divided by n, this value is going to close very to 1, and that's why it will become that time as a Z distribution. So if there is a large number of sample you are taking na, in any calculation, that time instead of T distribution you can also consider use of Z distribution. I think I'm showing the same thing here. Just a second. Sorry. Here. So if you are having a large number of sample, you try to understand, if I am having a large number of sample, then chi square by n will be very close to 1. And that means this value is close to 1 means T and Z is same. So one thing you please keep in mind for future is that if there is a large number of sample, then you can use Z statistics. if t is small, if the sample number is small, like normally we have 5 sample, 10 sample, then you should use t statistics. And if you know the t statistics, we can do the same job, same calculation. And that interval estimate we have already shown. So nothing changed. Only thing is that we are familiar with another distribution, which also depends on n number of sample is coming into picture in my definition for t. Because you understood that t, when I'm calculating t, I am actually dividing by the number of sample. You remember, chi square by n is there. That means t distribution value depends on n. I need to tell the number n minus 1, the degree of freedom I need to tell. So t distribution is kind this one. And how can I use it? Here, now coming to the final of this discussion of confidence interval. I have to stop it, otherwise our syllabus will never finish. So basically I'm coming to the point where I will use t distribution. Yeah. Now I will show you in practice also. Now I hope you understood that we have already used this one. You are so silent. Sometime I doubt you are all online.
Yes, sir.
Yeah. So you see, I can use a Z distribution data. When I will use, if I know population variance is known, which is not the case. Most of the time in our life, we will never know population this. So we can use it, but it is not correct. When it is correct, it is only correct if I am having very big number of sample. Most of the time I will be using a t distribution, which is also very similar equation. You see, x bar plus minus t alpha by 2n minus 1. Instead of sigma, I will use standard deviation by root n. So if I know, I can calculate, I can find out the confidence interval of any sample. A third one is there, which I will not use, or we actually cannot use that. This is not useful for much, so I will skip it. Otherwise, if I continue, I cannot really consider much. So basically, most of the time, I will be or you will be using this distribution, only the second one. Now, can I do some second one practice? Yes, we can do. But before that, we need to know the values. Someone is telling something. Someone is speaking.
No, sir.
Okay. Now, Z distribution, we have shown something, right? Today, I will also show you how to deal with t distribution. You understood the meaning of t alpha by 2n minus 1? Any one of you? If I say, okay, forget about t, I ask you simple this thing. If I say z alpha by 2, what does it mean? Anybody can tell me? If I want to ask you z alpha by 2, if I ask you, can you tell me what is the value of z alpha by 2? From table, I have shown you one table, right? The table is there. Can you find it out? Before you find out, or t alpha by 2, same story. Please listen carefully. Z alpha by 2 or t alpha by 2, what does the meaning? It is basically, I'm going to talk about this number, like minus 1.9.6 plus 1.9.6, like that. These values, na, that is called z alpha by 2. This is called minus z alpha by 2. When I'm talking about alpha by 2, that means, what does it mean? This area is. So this concept is clear. Now if I ask you, tell me z 0.05. If I ask you simply, how can you find it out? Because that is required, because the equation require that. You see, my equation required that. How to do that? So basically, for example, I'm asking I want to do at 90%, listen carefully. I want to do some statistics at 90% confidence level. Listen and respond. What is alpha? What is alpha? This is confidence level. Significance level, I told you. 90% confidence means remaining is significance. Just a new term, that's all. 90% is inside. So remaining is 10%. 10% means 0.10.
10.
So, yes, that is alpha. That conversion you must understand. So alpha by 2 means how much area? So what does it mean? It means that I have to find out this value where this area is just 0.05. Of course, my left, this value can be minus, okay? Or Z alpha by 2 means the area where my left side value is 90 plus 0.05, 95%. So Z alpha by 2 I can find out, Z minus alpha by 2 also we can find out. That I have shown you table. Same way for T distribution also we can do that. I will come to that point just right now, because I know the formula and I have to solve at least one problem, otherwise the whole exercise is useless. Let's come to the problem. So for example, I am measuring the effect of some fertilizer on plant growth. So I'm measuring the increase in root length or shoot length. For example, someone is getting 4.1, someone is getting 4.2, someone is getting 3.9, someone is getting 4, someone is getting 3.8, 4.3, 4.25, like that. Then I'm asking, okay, tell me what is the root length increase for use of fertilizer? How can I solve that? There is two approaches. First of all, first approach is that I'll talk about the principle, I'll talk about my calculation aspects, my formula, what I understood, that I can tell my limit. My limit is T alpha by 2 comma n minus 1. You see the formula? Formula is given. So you need not worry on that. Then first you will say, sir, what alpha I need to choose, that I have to tell you. So I'm telling, okay, you assume a 90% confidence level. So I'm assuming alpha equal to 0.1. You do that. So I'm going to solve my problem also with alpha equal to 0.1. So what I need to find out? I need to find out in a T distribution things, this meaning of this value, T alpha by 2, n minus 1. This value I want to look for. This is known T alpha by 2. Same portion, this side it is called minus T alpha by 2. Anyway, the number is same, minus 1.92 plus 1.92, like that. And this area is alpha by 2. This area is alpha by 2. I need to find out from T distribution. Can anybody tell me? I'll show you the T distribution first, and then I'll come. One problem at least you solve today. And then I'll show this is not so difficult. 1 second, please. So instead of Z distribution, you are using T distribution. I will come to, okay, this is the, sorry, what is the book? I think in lecture material. Yes, and we have the book, na research, sorry, the mathematical book. Yeah. And we found the statistical table in appendix, right? Appendix to table, I think, yes. Now we are looking for quickly. We are talking, okay, here we are going to talk about normal. Now we are coming to T distribution. Okay. So you see what you understand. from this table, even if you are very novice or newcomer, you can understand that we are talking about some number. You see, 2.01, 2.57. What does this number mean? It means the axis number, right? Not the area. And 0.75, 0.80, 0.85 means it is going to finish, right? 0.99, 0.995. This is talking about area to the left side. Now, for our case, this is the way they are giving. Now, degree of freedom is n minus 1. Now, tell me, this is my data set. How many data points are there? I think you can see my screen, right? Yes or no?
Yes, sir.
Yes,
How
sir.
many data points?
7.
7 data points.
7.
So n minus 1 means 6. Okay, I need to remember that because I am going so many formula. And then I need to find out T alpha by 2, right? T alpha by 2 means what we are looking for. That means left side of that alpha is, so okay, alpha is, I'll just write it, otherwise you will not understand. So that means we are looking for a point. Alpha by 2 means 0.05. So this area is 0.05. Left side of this, how much area? Whole left side of this, how much area? 0.95. Yes or no?
Yes, sir.
Whole left side of this. That means I am looking for this point where my left side area is 0.95. Okay, let's see from my table. So I'm looking for 0.95 to the left side. Yes. And my degree of freedom is 6. I got the value. Are you getting my point? So I'm looking for
Yes, sir.
95% area of my left side and my degree of freedom is 6. So my value is 1.943. Am I clear? 1.943. So this value I'll remember. And what I have to do for getting the limit, you see, now it is very easy. How to calculate? So this I know, S you know, and root n. So you calculate this and then I will come. What is the standard deviation of this data set? So for example, I'm calculating standard deviation of the sample. I got standard deviation, right? This is S. Means you will do manually, you will calculate average and you will do the story. And I'm calculating average. So for example, X bar. Do average of this. You can do manually also. So this is my average. This is S. And how many number? Number is 7. Now, according to my formula, what is the formula? X bar plus minus T alpha by 2. T alpha by 2 value I already know, 1.943. I will note down that. T alpha by 2. Alpha by 2 equal to 1.943. Now, can I use my limit? Now everything I know. So my formula will be T alpha by 2 into S by root n. So limit I'm writing, plus minus limit. Plus minus limit. I'm just writing. Okay. What is that limit? That limit is T alpha by 2 into S, this one, divided by root n, right? N is 7, square root of 7. How much getting I am getting? 0.137. So what will be the limit? You will say my limit will be 4.078. This is the number, and plus minus this. Do you understand how I am doing? Yes or no? Are you understanding?
No, sir.
You see, after so much time, you see, we are going to calculate this because I know I want to find out the distribution of our mean. X bar plus minus T alpha by 2 n minus 1 into S by root n. S is standard deviation. That I calculate it. And n is number of sample. Fine. I have to know the T alpha by 2 n minus 1. So first of all, first question, before you are solving anything, you need to tell what confidence level you want to have. So for example, I am telling I want to have only 90% confidence. So that you have to fix. So I'm assuming my confidence level or confidence interval I want to is 90%. Immediately I will say, okay, my alpha is 0.1. So alpha by 2 is this area and this area. So that's why in between my point will be 90%, yes or no? And this area is 0.05 because alpha by 2. Alpha is 0.1, alpha by 2 0.05, and this name is T alpha by 2. That means I need to know T alpha by 2 values. But how can I get it? I can get it because I already know this area is 0.05. So my left side area whole is 0.95. So I have to look for a point in T distribution where left side area is 0.95. How I'm getting that? I am getting it from my T distribution table. You see, this is 0.95 left side, and my n minus 1 degree of freedom, my degree of freedom is 6. So two things I have to check. So 0.95 and 6. What value is cutting? This is the cutting point value, 0.95 versus 6. That number is 1.943. That means I got the value of T alpha by 2 because I need T alpha by 2 that I already got now. This value I am getting now, 1.943. So if I know 1.943, then what is stopping you from doing any calculation? Nothing. This value I got 1.943 from my distribution table. Then S is standard deviation. That you are having 7 sample, I can do simple standard deviation. I can use formula. And root n, number of sample is 7, you can do. So just if I'm doing 1.943 into a standard deviation by root n, is it a big job? No. I'm doing the same thing here. I'm doing nothing new. You see? So I'm doing average of the sample. This is my sample. I hope you understand. You are not starting from the scratch again. This is my sample. What is the average? You calculate average. I'm not doing. You sum and divide by number. You do. And standard deviation. Standard deviation, you know the formula, but I'm using formula, simple. Excel, I can use formula. But if you want to do manually, you do. I have no stoppage for that. N is number of sample. Everyone knows. T alpha by 2, just now I calculated. And what is my alpha? By the way, I have not told you my alpha assumption. My alpha is how much? Any one of you can tell me?
0.10.
Very nice. But I should also write that just for reference. So what is my limit? Limit is, you see, I'm saying same thing. Limit is T alpha by 2 into S is 0.186 divided by square root of 7. If you do this calculation, it will come 0.13716. So what is my limit of my, so how can I say my population mu? So I'll say confidence interval of my population mu is 4.07 plus minus 1.316 at 90% confidence level. I'm using T distribution, and that is always correct. Now, I hope you understood. If not, then I'll speak later on. Now I'm coming to the last part. Okay, sir, I'm doing so much things. Is not there any tools? Because when you'll be using your in day-to-day life, do you think you will remember all formula and you will do all those, go to T table and do all those exercise? No, there is some options. I'll show you now that part. So for example, I want to do the same thing. So this is my data. You listen very carefully and you can have very easy solution. In my Excel, in under data column, there is one data analysis tool pack. Excel will do the job. You need not do. I'll show you how. So what I'm going to do is, for example, in this case, just a second. Or yeah, we can use this one. Data analysis we are using for descriptive statistics. No, Moving average, no. Random number, rank and percentile, regression, sampling, paired two sample, no. I can use this, but let me see. No, I'll not use that one. I have something else. No. One second. I think Excel has some options for that. Let me see. We are going to get confidence interval, right? Okay. I'm sorry. I'll do it here. Confidence interval on T. What is my alpha? Alpha is 0.1. What is my standard deviation? Standard deviation is 0.186. Sorry, 18676. You see, I'm writing, and size of my sample is 7. How much value I'm getting? You see. You see what you learn, is it useful or not? Yes, you can do. So I can find out this value is 0.13717. And how I'm getting it? I'm calculating confidence using T distribution, and it is telling you. You need not memorize everything. It will tell you. You see, when I'm putting this, it is asking alpha. Alpha is 0.1. So I can say easily this is 0.1. Then standard deviation, I just now calculated. And size is 7. So you always need not memorize. I'm getting 0.13716 by formula. And when I'm doing manually calculation also I'm getting. So I hope you understood this point. Is it okay to understand? Yes or no?
So could you show it again, sir?
Okay, this I have already shown you, right? And this I'm going to say, okay, that whatever I have already shown you, it is having few more steps, right? I'm going to T table, and then I'm getting the 1.943, then coming back and doing the calculation. Calculation means I'm doing alpha by 2 into S by root n, that I'm calculating myself. If you don't want, there is an option for you, and this is being recorded, so you can always check. So I'm looking for confidence using T distribution. You see, T distribution and normal using T distribution. So if I'm using T distribution, it is telling me, you see, asking few values. You see the write up alpha, it is asking. I'm giving the alpha, then comma, standard deviation, it is asking. This is my standard deviation, comma, size, it is asking. So I'm giving you 3 values. and then enter. I'm getting 0.13717 by formula also automatically, and by manually calculation I have also done. You see, number is nearly same, 0.13717, here 0.13716. That means I already got the distribution. Now if I ask you, I want to do the calculation for, you tell me now, if I want to do the same calculation for 80% confidence interval, what I will change in this case? If I want to do the whole calculation at 90% confidence interval or 80% confidence interval, if my 80% confidence interval means what is my alpha? Alpha is remaining is 20%, 0.2. Then what is my standard deviation? Standard deviation is this one. And what is my size? Size is 7. Done? You got my point? Anyway, you are so silent, so I'm just stopping it here. Anyway, time is over. If you understand, if you want to go through further, you can always check the recordings.